Denis, welcome on the Tech Recruitment podcast. Welcome on the show. It's super cool to have you here because you specialize in something that I know very little about. And that's just so cool to learn from your experience because I think a lot of recruiters out there and people who engage with, with the technology or with biotech, for example, or with genomics, like they may not know anything about this. So thanks for joining. And
Thank you.
yeah, and
No, thank you, Mika. It's great to be here. It's wonderful to share sort of a different view of the world, more from a academic, PhD perspective, rather than the standard IT crowd that you usually feature on this podcast.
yeah, so true, so true. And you are also the AWS hero, right? So you use the Amazon Cloud at work as a researcher. So why don't you tell us a bit more about how it works? Because as you say, like we know how it works for web developers or for cloud engineers or DevOps specialists, but how you take advantage of the AWS Cloud?
Yes. So backtracking a little bit, I'm a research scientist. So I develop life science tools and technology in order to analyze data to understand better how health works and what we can do about it in order to live healthier lives for longer. And as you can appreciate, there is a lot of data that is generated in this space. So specifically with the human genome being 3 billion letters for a single individual, that is a lot of data when we're dealing with hundreds of thousands of population scale cohorts of individuals. And for that, we do need to have the appropriate amount of scale and compute. And typically, we develop something as a prototype on small samples, but then we need to be able to scale it up to these hundreds of thousands of cohorts. And for that, when we think historically, where you had one compute and then you need to buy more compute in order to scale it up, that wasn't sustainable. And therefore, going to cloud providers like AWS or Azure enables this scalability, this elasticity. And that's sort of the main thing what attracted us to the cloud first. But now there's so many more reasons for going to the cloud for us as researchers. And one of the main things is global connectivity. So being able to collaborate with our colleagues in Europe or the US is absolutely vital, and the cloud enables that capability too.
Oh, it's just the numbers that you mentioned are kind of mind-blowing, right? I was just having this DNA test recently, and they were just explaining me how many of these sequences there are, and I cannot kind of comprehend the numbers anymore. And now we need to multiply it by thousands or hundreds of thousands of people. So those are big data. And then in your setup, for example, how it works if you need to scale, for example, like you are a researcher, right? So the AWS Cloud or any other is quite pricey at the end, right? I'm just gauging from my experience when we were running some like little operations. So then how is it financed eventually?
Yeah, that's a good question. Which is sort of the number one question, at least in the research world, that scares people from making that jump. Is that whenever I talk about it, people say, "Hey, Dennis, what is it when I let it on overnight or forget about it, and next morning I wake up with this huge bill?" Um, that is absolutely true. The learning curve of using cloud appropriately is real, right? So, but there are guardrails around that prevents people from having exactly that overnight shock of having forgotten something to leave it on. And similarly with the cost, usually it's not that it's accumulating overnight unless you forgot something, but it's sort of gradually, and there's a forecast in the system where you can see how you're operating. And there is like the malpractice can lead to big bills, especially in the research world, where it's the egress cost that sometimes can kill organizations.
Mhm.
But usually the cloud providers are good in advising you on those on the next journey. So you might have your operation in shipshape today, but they're advising you on the operations going forward. What kind of costs will be there? Plus, there are obviously tricks around using spot instances rather on-demand instances. For us, we went one step further and went cloud native in quotes, which is called serverless or function as a service. And therefore, when you take apart these traditional monoliths and restart building them in the cloud natively, there's a lot of cost saving to be had, because then you don't have stuff that is running in perpetuity, even if it's not used. Say um, a instance running a database, for example, that is not needed. You can have the data in something that is serverless like DynamoDB, and then you only get queried or you only get billed when you actually query the data. And that again is a huge cost saving. So there are little tricks that you can apply as you get more advanced in the system that reduces the cost and the risk of racking up a huge bill dramatically.
Awesome, awesome. Well, this is it's just so cool to listen to you to talk about AWS or the cloud or the strategies, right? Because you are the mathematician. You are the person who has not really studied IT or cloud, at school, for example, right? It's different with cloud engineers or computer scientists, but it looks like now cloud is getting to all of these other jobs where it was not very common to talk about Lambda functions and serverless. So based on your experience now working with the community, do you see this shift as well, like with your colleagues and with other people out there who are kind of learning about how to use cloud?
Massively. Yes, yes. So you alluded to my background. I'm a bioinformatician by trade, which means my undergrad was in IT, but also in math, stats, medicine, biology, you name it, sort of that whole domain of life science that we needed to have a good understanding of too. And plus, I'm old enough that cloud wasn't a thing when I went through my degree. But nowadays, I sort of see this real shift that cloud is taught in university courses and is readily available through Cloud Guru and other systems where you can learn it yourself. And, and therefore, I see more and more people actually having the accreditation of a cloud practitioner, and all the cloud providers offer that, which I think is absolutely critical to really demonstrate that you have the chops, that you have the skills, at least theoretically, of what you're talking about, because of this risk of malpractice in the cloud. Um, and therefore, having these skill sets demonstrated is something that I think people gravitate towards more. And when we recruit, even in our research space, we do look at this and see an AWS cloud practitioner accreditation, and do take this as a positive point for the candidate.
Very cool, very cool. It's just unbelievable how cloud is getting to all of these jobs that were not very common just to know about Lambda functions or DynamoDB or others. Awesome. And just a few days ago, there was this International Women's Day. It was last Friday, and in another setup, we were discussing that also often women are scared of the technology, that they struggle getting into IT, or I mean, in your case, it's slightly different twist to technology, but still you are operating within tech. So, what do you think about the transition from someone who has never been working in the technology space, not just IT, but the technology space, like, and they may worry about the environment. They think this is too technical for the female person to be in that room. But you are a woman as well, right? So from your experience, what it is like, what would you suggest other women do to overcome this fear?
Yeah, sure. I mean, when I went through my undergrad and before being in the technical space, I do look around the room, and I was the only woman there, which was
Mm.
great for the toilets because there was no queue whatsoever. Whereas looking at the boys in the toilet, there was always a queue, which in real life is usually different. But nowadays that has completely shifted. Like now I do see 50-50 representation, which is great. So let me answer then your question more as a gender agnostic answer, in that everybody has the fear that the space might be too technical because it is moving so fast. But because it's moving so fast, when you learn the thing that you learned today, you're automatically ahead of the pack who has learned it yesterday, right? So what is it, 3-4 services per day that cloud providers, new services per day that cloud providers put on. If you become the expert in these services, then that is gold, where you are far ahead of everybody else. So at any point in time, you can jump in and become the expert in that new space. And I think this is why I love cloud so much. It doesn't stay still. You never know what the next thing is around the corner, and you always have to be agile.
That's such a great advice. I haven't really realized there are so many new features being released, but just in the recent AWS reInvent, they had the list of what, 50 announcements. So kind of
Yeah, exactly.
makes sense. Oh, wow, that's just crazy, really. And before we kicked it off, I was also saying that I'm in IT for about 18 years by now, but it really feels like every year, every month, I know less and less about IT
Yes.
because there is so much new stuff. So totally true. Cool. And coming back to you being a part of the community, you are part of the researchers community, right? And a lot of recruiters who are listening to this podcast, they often get job requirements from clients who are looking for PhD researchers or for people who are experts in a certain domain and might have written some papers, for example, in the past. So, based on your experience, what would be the best way to tap on this talent pool of people who are probably hiding, a bit and not as active on LinkedIn, not actively reaching out to recruiters? How can we as recruiters get to someone like you?
Yeah. I think my recommendation for the recruiters will be to ask the client what they actually want. Because with a PhD, yes, you get an expert, you get a person who has gone through their thesis, like a 3-year process, and don't give up, right? So you do have that trait in the character of people banging their head against the wall and not giving up on a problem. But also you do have the trait of people going down the rabbit hole, of people wanting to go to the bottom of a problem and solve it and prove it and sort of have that aspect to it, which may not always be the right trait in a commercial company that just wants to move fast and wants to cater to the market today. So you do have to train or help these people unlearn the skills that they learned for their undergrad, their graduate, and then their PhD, to be so, a dog with a bone.
That's
Yeah,
that.
so that's what I find. Myself and the people that I hire always fall into that trap of wanting to go down and then sort of consciously needing to pull us out and say, okay, what is actually the problem that we want to solve?
Mhm.
And with that in mind, getting these people, like finding them, is also difficult. Usually they will hide in their academic world because this is what they're used to, right? So I'd say you find them in forums which talk about specific issues. You find them certainly in the publication era. So when you go to Google site Scholar, then I think having people on the paper, and then it also depends on where they are in the paper. In different domains, you do have the first author is the person who has done the work and is probably the one you actually want to have, unless you're recruiting more senior where you want to have more a strategist and a thought leader, then you're probably looking more towards the back of the paper where the senior author is that has led that certain area and has developed the thinking behind the approach.
No, I thought it's the other way at first because I thought, the person who has the most credibility is at first, and then the others are somewhere in the back. But it's good to
It
know.
depends. Yeah, it depends on the domain. So in the physical science domain, I think it is that way around.
Mhm.
But certainly in the health domain, it is that you have the people doing the work at first, and these are the ones that are cited because typically these are the younger ones that need the actual publicity, if you want. Because when you cite it in a paper, you name the first author et al. Like and the rest.
Mhm. Yeah.
And therefore, when you talk about method X by first author et al., you always say first author et al. And you never mention the last author because they are typically the established people in the world where you say, ah, yeah, of course it was them.
It's about those people, right?
Exactly.
They have all the credit already.
Exactly.
Awesome. Cool. And since you focus on genomics, what are some like really cool applications that you've been working on? I'm just kind of thinking about the research and then the application of the research in the kind of real world that we, the normal people, can actually understand. So are there any interesting examples that you could share with us so that people can also visualize what it is like to do some research and then use cloud to, do some application with it?
Mm, yes. So our genome is sort of the blueprint of our body, how it's built, and what kind of future disease risks we might have. And therefore it holds the information about our health, and therefore it should be used in order to make health decisions. Be that around, what kind of cancer do you have, because there are different kinds of cancer that respond to different drugs, or how you actually respond to drugs. So with warfarin as a blood thinner, it's really crucial how high your metabolism rate is for that particular blood thinner, whether you need to give more or less. And all of those things would be encoded in your genome, but it's currently not really used in day to day medicine in order to really make informed decisions about us or personalized decisions about us. And the reason for that is, as I was saying before, the genome is really freaking large, 3 billion letters.
Wow.
And while the cost of actually sequencing those 3 billion letters has come down dramatically, our understanding of which location in the genome does what is very much in its infancy. So we do know about, blood thinners in those 3 locations in the genome that has an influence on it, but we don't know what millions of other locations probably also have an influence on it. And that's the research that I'm doing. So looking at what disease genes, for example, for cardiovascular disease or Alzheimer's disease, are in the genome. And not only individual genes, but for complex diseases that really impact on the healthcare system, it typically is multiple genes that work together, if not the whole genome. So we do have things in the genome that makes us more resilient, but we also have things in our genome that makes a certain mutation much more aggressive. And understanding that is a complex space. We're using machine learning to really look at the whole genome and making assessments around that. But then also the point of having the right representation. Like the majority of data, I think it was 80%, is actually Caucasian because that's historically where the sequencing was developed and generated. But our populations in the modern countries are not just Caucasians, right? It's a mix of different people. And if we want to cater to those, we do need to have a good understanding of those mix because your ethnicity influences the way you need to be treated. There's certain diseases that certain populations are much more susceptible to, and that needs to be reflected in the best practice of how to treat people. And we currently have not a good representation of that. There are certain projects around the world that try to lift the representation of those people so we can actually study that data. But that, of course, comes with the caveat of that privacy, data sharing, all of this needs to be taken into account because the genome is ultimately the personalized, most identifiable thing you can think of, and it holds all the sensitive information, again, you can think of, and therefore needs to be treated with appropriate care.
Yeah, yeah. Well, you don't want to, this database to be hacked at some point, right? Um, awesome, awesome. Well, now it kind of I have these flashbacks to the DNA test that I was taking some time ago, and I kind of try to visualize what does it look like with these. Did you say 1 billion or 3 billion letters?
3 billion.
Letters in the genome. So how does it work when you have these letters and then do you compare person A and person B and person C, one with the other, and you look for some similarities?
Exactly. So this is what is called genome-wide association testing, or GWAS, that people have thrown around. And traditionally, this has exactly that. You can think of the sequence of one individual as sort of a string, and then you have thousands of those strings. And then for each location, you line them up so that each location is the same location. And then you compare across it. And if there some group of people that are sick have a mutation, and people that are healthy do not have that mutation, then that is strong indication that that mutation has some influence on the disease.
Yeah, well,
But as I said, it's not a single location. It's the multitude of locations and how they interact with each other. So machine learning is your friend.
yeah. Well, on the surface now it looks kind of straightforward. You have
Yes.
and some anomalies. You just, to say. But of course, it must be nightmare, to look for those anomalies. But now with the cloud and machine learning, it could be definitely easier. So it's just coming back to the cloud. It's kind of interesting how cloud makes these jobs easier because I try to imagine people how they did it 10 years ago, just manually writing those 3 billion letters. Probably not, but
Yes. There were essays where you actually look at each one of those locations in the genome manually on a film of what is it called, like the tissue film, and you track, there's an A, there's a C, there's a T.
wow, no.
Yeah, no, we have come a long way since then. And I think what keeps us going is that all the concepts are straightforward. Like, we want to improve human health. It couldn't be more straightforward than that. And therefore, the complexity only hits you when you actually are in the weeds. So, for example, another easy, straightforward thought is that we want to be able to share these genomes around the world so that a clinician, on one side of the world can query all the available genomes in the world and can say, the person my patient has this particular mutation and has these 5 symptoms. Is there anyone in the world that has the same profile? And can we compare treatment choices in order to come up with the best idea? That's a
Mm,
straightforward idea.
wow.
Of course, the devil is in the detail, and the cloud, though, is helping with that, though,
Mm,
because when we move those genomes into the cloud under all the security and privacy and governance regulation, we can then link genomes that are generated in Australia with genomes that are generated in Europe or the US or other regions of the world. And
mm,
therefore, a clinician that might be sitting in Brazil could query that data easily because it is available and it is connected.
mm,
Of course, now we're not talking about population scale
mm.
genomes anymore, like one population, 50 million. We're talking about, the world's population. So we're talking about billions times billions.
Oh, that's a lot of
That
letters.
is a lot of data, yes. Yeah, and
Awesome.
we developed an algorithm that not quite scales to billions. So we've demonstrated it for population scales of 50 million
Mm,
times 3 billion. But
mm,
it is a way of parallelizing and retrieving the data in parallel from multiple resources around the world that are under due restriction of the individual states and organizations, and we
Mhm.
can query across them in a federated way. And that again is a serverless
Mm.
application, so function-based application currently running on AWS.
Nice, nice. Well, I can imagine a lot of people listening to you right now, or right now. I mean, once it is released, they would be quite excited, and they would be willing to kind of leave their current job for something as exciting as this. But the little obstacle could be that they probably don't have, 5 years to study, a PhD or, something more advanced. But they still may want to be a part of this. So, based on your experience, I mean, are there some roles kind of somewhere in the middle, like not as advanced as you are, but still technical? Like, how can people,
Mm.
in other words, get to work on these projects, but without spending 10 years in the academic sphere?
Yeah, absolutely. And I do get people quite a lot come to me and say, I want to work on something that really matters rather than shuffling data around. And I agree. It resonates with me because that's the reason I'm in this space. The thing to consider though is that the pay in the academic space is abysmal. So you are quite likely better off in your job that pays decently rather than giving that up for working on, um, you know, a social good problem, if you want. So my recommendation to people would be to say, maybe you can volunteer with us to do the works, to bring your experience in the space of IT to us and help us uplift our capability. And because this is how we learn, right? We don't um, have the luxury of time, if you want, to go through and study IT, whereas people typically in the IT space, especially when they're working in that domain, they have that at the tip of their finger and can contribute that readily. So therefore, not giving up the very well paid job, but still contribute to something that where it matters.
Well, that's a
So
very
definitely get in touch with me if this sounds good.
That's a very thoughtful advice. Definitely makes sense regarding the compensation and everything. But then, what do they? How do they reach out to you? Do they just say like, "Hey, Denise, I have some spare time. Would you want to use my expertise?" Is it as straightforward as this?
It is as straightforward as that, and we did have volunteers quite in the past, quite a number of them in the past, who are, for example, porting our technology from, say, AWS to another service provider.
Mhm.
Because again, in our space, well, we have one solution. We don't have the luxury to then invest more money in that in order to replicate to make it more accessible. But
Mhm.
in especially the genomic space where the data is so large, it is located on different cloud providers. And
Mhm.
therefore, ideally, you bring the algorithms or the solution to the data rather than trying to open a portal
Mhm.
um, to the security policy and whatnot requirements in order to connect to data sources. So it's much easier to just develop an infrastructure as service or infrastructure as code
Mhm.
template and put that into a different cloud, so Terraform template or whatnot. But that requires some skill as well, where you need to compare one service to another service because they're not, as we know, they're not
Mhm.
one-to-one comparable unless it's something as big as an instance. But as soon as you go down with the intricacies of cloud provider in the serverless space, there are differences. And therefore, being able to port these technologies that we have developed. So, for example, Variant Spark is our machine learning method for analyzing genomes to identify those disease genes. And it is running on AWS. It was the first public sector organization to have released that on the cloud marketplace, the AWS marketplace in 2019. And then in 2022, we released it on Azure. And now we're looking at GCP. And it would be great to have our other technologies for example, the tool that enables the sharing of the billions of
Mm,
genomes so that clinicians can type in and ask whether that patient data is available somewhere else.
mm,
That is called serverless beacon. And that technology currently is only on AWS, and it would be great to have people look at this template and say, here are my skills in Azure and GCP or Oracle or whatnot, and then port that over. And that will be a fantastic
mm.
opportunity, I guess, for a volunteer to showcase their skills, get our eternal gratefulness, thankfulness of the academic and clinical research world, and do something that is fun.
Awesome. Well, it just sounds so inspiring. I will promote this podcast not just within the tech recruitment community, but also among those cloud engineers, because I'm
Thank you
sure
so much.
I'm sure a lot of people will be really excited about just hopping on this opportunity to help you and utilize their skills. So yeah, just to be mindful of your time as you have an appointment scheduled. Where can people connect with you if they would like to help you or connect or discuss something? Where can they find you?
Yeah, the easiest would be to hop on the web and search for bioinformatics.ciro.au. So that's CSIRO.au. And
Mhm.
there you should find our webpage, or our blog posts, and the products that we developed or the software tools that we've developed. And just pick and choose, kid in the candy store.
Awesome. So I'll include the link in the show notes, also on YouTube in the comment section. So wonderful. Well, it's been so inspiring. I could listen to you for the next 2 hours, but I guess we need to wrap it up. But they say that we should finish and in the best part. So it was just so much fun speaking with you and learning from your experience about not just AWS but also genetics and how it works with these genomes. So thanks for sharing.
Oh, my pleasure. My pleasure. Anytime.
Wonderful. Thank you. Have a wonderful day.
You too. Bye.